gonna start. I'm just waiting, like, thing. Yeah. So we're going to start about now. So let's introduce first loyalty labs or zero gravity labs. Felipe, where is Felipe?
Hello everybody, welcome to Zero Gravity Labs. My name is Felipe. So I'm one of the science Zero Gravity Labs together with Victor that is just hanging out in the back. So just a little bit about us. So we are the research and innovation part of Loyalty One. Our mandate is just to explore and play with new technologies. So we do everything from artificial intelligence, deep learning, machine learning, IoT, VR, AR, quantum computing. We just check all the technologies and we just play with them. Lately we have like fancy new toys, so we have been playing with HoloLens. Let me tell you, it's extremely cool. We have tons of fun playing with it. So yeah, that's us. Welcome to our labs. And if you have any questions about us, just let me know. We are currently hiring. So if you're looking for a position, we're interested. I think that's it. Is there anything else I should mention?
No, I think we're good.
Okay, so where is Henning, by the way?
He's on his way.
Okay, yeah, because you guys know how to, like, ladies, you know how to use the ladies' washroom, because there's a special procedure to go there. The procedure is, I think, is right on the board. Felipe? I don't see from, yeah, ladies' washroom. So there is a code, press 1 and then press something.
Press 1 and then press 2 and 5 at the same time.
Yeah.
Press 1 and 2 at the same time and then 5.
Yep. So, okay, so let me introduce myself. My name is Ian Antek. I am quantum machine learning developer for ArtistQBNet. I am serial entrepreneur. I have 12 companies already. All software companies. I'm a professional musician. I'm from Venezuela, Caracas, Venezuela specifically. I'm here today because I'm mixing two of my passions. First of all is machine learning, AI, everything that has to be related with a computer. And the second of all is music. Because first in my life came music, and then opened my mind to actually algorithmia and composition, so why don't mix it together, right? So first off, so what I have here. So I have two core keyboards. First is the Core Chronos, and this is the Core Oasis. They are both got enrooted to a laptop that is running all my concert. It's running all my Python notebooks. Okay, I want first to know how many musicians are here. Two musicians, right? Okay. What instrument?
Guitar.
Guitar? Okay, so you're playing with me, and you?
Produce trance. So
okay. So you will like what you're going to see then. Because I don't want to take your job, but that's good that you're here. Sorry. So let's talk about a little bit of what I am doing right now. So I am not taking your job yet. Yes. Because this is augmentation. Augmentation is like HoloLens. It's still reality, but with some, let's say, holograms, right? So my AI, Rhapsody is called, what it does is use sentiment analysis to actually build music on top of words and meanings. So you say a word, you say a meaning, and it creates the bass, and then load this to my keyboards. So this is not only what it does mashups, it does also style transfer of music, it also do edit videos based on MIDI files, and then mix everything together. So what you are about to see is about 1 week of 10 GPUs render hours. Okay, so, well, actually one of my servers fails rendering this. So I'm going to do the 4 demos first. So the first 4 demos is first Anomalie. Anomalie is a Canadian musician that does something called it's like electronic jazz music. So I am playing on top of that. I am adding some machine learning on top of that, augmenting the track itself, doing using a project of Google called Magenta that basically renders waves on top of that. So I'm loading the patches into the keyboards in real time. These keyboards run Linux, so this keyboard I modified. This is my own keyboard. This have a motherboard and have 2 graphics cards on it, so the concert is being rendered real time here. Just going to do a introduction of what the keyboard sounds like without AI. Then I'm going to add Karma, which is a technology of Korg that let me basically put in real time MIDI files and have scenes like Live 8. I don't know if you guys are, yeah, you are. What's next is that I'm going to start playing the 4 demos that I created, the 4 1-week GPUs, 10 GPUs, crazy demos I did. Okay, so what it sounds like a keyboard with a core keyboard without AI. So like a normal keyboard, right? So right, and this one I have patches preloaded. I don't know if I think you see, is this on? Yeah. Okay. So, like more keyboards, more single sounds. Like for example, okay. And now I'm going to play the demos. Okay. So the first demo is Antek plus Anomalie plus AI. So the video you're going to about to see is being rendered by few layers. Okay, the first layer is a iTunes visualizer that is being controlled by OpenCV, which means I'm actually backpropagating the images I see, and then I'm going that backpropagation back to the controllers and real time modifying the animation based on the peaks. Okay, at this point, who doesn't understand me? Okay, I will go through this later because you're the minority right now. But I'm sure while I'm getting more and more deep, you need that. You need to ask questions. Okay? So first demo. So that's the first demo. Thank you. So, any questions so far right now? Yeah?
Yeah, it was just, can you clarify kind of during that performance, again, what was you and what was the AI?
Yeah, so the AI at this point was augmented, which means that the AI gave me like insights, what I have to do. So this was pre-rendered. Everything you're seeing right now is pre-rendered. I'm going to do a exercise with tweets after this. This took 1 week rendering, like I already said, like 1 week rendering, so that's why I'm pre-recording everything. So all the animations was AI driven, which means the visualizer itself is an iTunes visualizer, but the AI is driven this visualizer, which means that it's OpenCV, just seeing patterns, and the patterns that I want to see, I have to back propagate it, and I have to later like control MIDI file, like MIDI input to the visualizer to actually get what I want. I didn't do anything of the video, I just did the vocoder part, talk box part. That was the, I don't remember the part right now, whatever. But you saw like me singing the video. So that animations, I was using feature extraction. Like it's just how the AI see the things to extract features. So the video of me singing is not a fact. It's just a Python script that is just extracting features from the highlights. So that's what I did in this video. So this video, I'm starting from low-level stuff. Yeah, low-level stuff, so it's simple. So each video is going to be more complex than the other. So this is just how I can add. The other thing I use for an AI, some patches, for example this one, is a rendered wave. So this rendered wave is using Project Magenta from Google. So it's kind of like the division of Google that makes music, yeah. So I don't like it, but whatever. Yes?
So was the audio also a product of the AI or not?
Yes, some of the audio. So some of the patches, for example, this one is a rendered AI. It's a rendered sound. So what I did I can show you the notebook. It's something like this. It's a synthetic, wait. So this is an example I did of how, okay, this is the heavy part. You want to listen this later or now?
No, no. Data scientist. Go ahead.
Okay, cool. So, what I did is just I graphed the harmonics of the original THX. Let's see if I can play it for you guys. Just one sec. It's running on one GPU instance I have on phone, but I don't know if it's going to render. Yeah, it's rendering. Okay. It's here.
That's hosted back into a bucket right now.
Yeah, it's all the GPU instances I have. I don't use Amazon Web Services. I build my own servers.
So is it on the Titan? Is it on the Vue?
This is on the C800.
The new ones that you just bought this week?
Yeah.
Okay.
So, also this keyboard have 2 GPUs. So the thing I'm going to render, like this is a custom keyboard I built on top of the Oasis. Oasis stands for Open Architecture Systems Studio. This is a 2005 keyboard that Cork did, a special edition. So what happened is that this is essentially a Linux operating system, and the hard drive is not encrypted, which means I can just clone the hard drive, and I can just tweak my system. I can add drivers, I can have root access to the operating system of the Oasis, I can add PCI Express, etc., 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 because it's a computer. So the operating system is on GitHub. Everything you're seeing right now is on GitHub, even the deployed version, which is not working for some reason. Yeah, when you want to demo, it's not working, whatever. Yeah, like it's here, it's here.
Yeah, and you know, Cell is rendering, but not anything.
Sorry, guys. So eventually we'll do the render.
So in the upper right?
Oh, the current lag. Yes,
The current live.
That's right. Do you have that notebook saved?
Yeah. So I should just say launch the game?
Yeah.
Is it running? Saving, okay, let's see. Okay, so let's just do this. Okay, it's execute, cool.
There we go.
Oh, no backend, no! Okay, so the backend, that's okay, I don't need to listen this. So you know when the pictures like THAs is so the graph of that, because it's not rendering the audio, okay, but it's rendering the original wave. Okay, so what you're seeing here is a graph of harmonics. So you guys know what a harmonic is? So you have let's say you have a wave, a sine wave. When you duplicate the wave, it's the same note. Like, okay, let me explain you with orchestra. So you have a wave, you have the 5 harmonic, the same harmonic, but it's doubled, it's the octave, you have the 4, and then you have the harmonics that are not symmetric, like, well, I don't have a board here. Yeah, I have, okay. So let's say we have a wave, right? And the double of the wave, let's count that this is perfect, please, sorry.
Can you put it a little bit forward so that I can see?
Yeah. So this wave here, like, this is Fourier, okay? You can represent a complex wave in less waves like sine waves and saw waves that are composing the original wave. But this is a simple wave, there is like a music, the sine wave. So when you have harmonics that you're seeing here, is that you have the main harmonic. Okay, so you're amplifying the other harmonic. So you have the fourth, which is this one, which is inverted. So if you if you play, like, this is going to cancel, no? Because, like, if you sum this wave, sorry, if you sum this wave with this one, it's going to be 0. You know what I mean, sorry?
It's waves of superposition. I mean.
Yeah, waves of position cancel each other.
Yes.
That's really neat for music if you want to extract, for example, like a cappella from a cappella is just the voice. So you recreate the music and then invert it 180 degrees, and then you cancel the music and you get the voice. So that's neat for music. So harmonics are essentially waves that vibrate or resonate with the main wave, which is in this case the original one, this one. But what is neat about this example is that basically you are pitching the harmonics until you have a perfect octaves. So let's say I have the synthesized version of this. I don't have the original, but I know you guys have listened to this before. So, well, I have to tell you here's something weird. This original. Pitching harmonics until you have the perfect one. That was created in Super Collider, by the way. It's a software, like an 80s software that they use on Star Wars, which is really neat, but we don't have like infrastructure to run it. It's running with the 95. So that's how you synthesize waves. And all these explanations, how this thing was implemented in the first demo, right? So what I did is I show a wave, a bunch of waves, to a machine learning algorithm that I don't have to patch. I don't know how to create this wave. Like, let's say, you know how synthesizer works? You have a wave and you have oscillators. So each oscillator is a different wave, and then you have filters that filters the wave phase and filters everything. So if you are lazy like me, what you do is use a machine learning algorithm to set up everything. If you are not lazy, you set up everything by ear. That's how it works. So how I did it, I need the patch. I need the original patch, but I don't have it. This is not perfect, obviously, but I need the original patch. So I show a machine. I show the algorithm, the patch, how it's being, let's say, the original patch, and the machine tries to adjust the parameters with generational algorithms until you get something similar. So the original patch is, sorry. So that's the original patch of Anomaly, so I'm duplicating it using AI. That's the part. So that's how I did the machine learning implementation here. By the way, all of this is available on GitHub. I have even the notebook running with a nice GPU. So if you want to try it out, it's going to be on Slack right now. By the way, if you are on Slack, go to the channel and the PO. I'm posting everything. We're going to use this later. So after the next song, I'm going to I need to start rendering the songs that we're going to do live. Yes.
So I'm a pianist. I do like piano compositions. Where do you visualize this fitting in my pipeline?
Okay.
When I'm working, how is it going to?
That's amazing. That's something that I will answer you later because you're going to see the part from the Python notebook. Okay, it's using MuseScore. So what I do is I use MuseScore as a backend. You know Sibelius. You know, like you know composition a little bit. So you have a sheet like a music notation software. So the music notation software is MIDI, which MIDI means music instrument digital interface. This MIDI interface is a file, it's a digital file, so XML file. So you guys can extract a lot of features from that. You can extract from, for example, all of this, by the way, is driven by MIDI. So you're seeing real time when I'm playing here. So this cable runs audio and MIDI. This cable runs MIDI. So this keyboard here is through here, and this is through here. So this is just for visualization purposes. I'm not playing here anything, but if I want, I can add virtual instruments. So for example, if I want to add a magenta sample, I just go here, instrument, and then just I see like a bass. So I can add, this is a computer. I can add like the Kronos instrument plus the fretless bass in this case. So these are kind of like for example, an ARP if I want to. So what it means that in real time, I can manage to have a keyboard as a computer keyboard. But this doesn't stop here because this is recording a lot of features. You data scientists, I know you know that, or you love the features that are explicit. So a MIDI file is explicit. I mean, like everything is explicit. So because it's an XML, you have a MIDI stream, which I'm doing right now. And you have the MIDI file without the, I can show you later how is everything being played by the machine, the MIDI stream. Yes?
You're using the notes that you play as features for training later? Or?
Yeah, every single note has velocity, has expression, has pitch bend. Like, let me show you like with a quick example. And I want you guys to hear what I am playing with one note and tell me how many features you can listen from that exercise. Okay? Go to the guitar. Well, whatever.
Hit me, hit me. It's dangerous to be around. 7 nights a week I wait, I didn't see your bomb. Double bring me down. like this don't happen anymore. Oh yeah. I need to know, is it me and did I lose control? Overseas, memories that keep taking over. Come, don't know. When I felt before our eyes, oh yeah.
Basically, I asked them to send me the footage and send me the music without keyboards. I played live keyboards, and I let the machine edit the video with the MIDI file. So far, it's just a mashup of dirty loops, but this was already like they did the mashup, not a machine, just the machine edit the video. This kind of like you can put a machine with After Effects and learn After Effects, and then just literally do whatever you want and give me a video. So, any questions so far? Yes?
Yeah. Would you mind elaborating a bit more on the training process and how?
So Librasa. So for the training process, you use I use TensorFlow. I'm using Keras too. Depends of what I need. Like if I need a quick neural network, I just use Keras. If I need like more tweaks, I use TensorFlow. If I need like really nice support, well, like Keras is a TensorFlow, like a backend TensorFlow, right? So you have everything you have entered in TensorFlow, but you can literally have like build like a convolutional network in, I don't know, like 10 lines. Yes?
Can the AI make composition?
Yeah, we're doing that. We're going that later.
Can you give it a little?
Yeah, you can, but the thing is that since I told you guys that there is a bunch of explicit features, there is a bunch of implicit features, and I'm talking about thousands of features, like implicit features. So a machine to be fully automated, probably with quantum computers, to build like a really meaningful piece, because otherwise it's just serialism. You know what serialism is? It's just put numbers in music and doesn't, even though it doesn't make sense. But the machine to have sense with sentiment analysis that's going to get there to the next chapter. It's going to be a really, really well implemented algorithm that is, because it's factorial. Every time you play music, the possibilities are factorial and not exponentially, they're factorial. So,
Make one comment there.
Yep.
If you have very strict rules, like for instance the Bach cantata, they could train that in the 90s to compose that out like the last very structured way or a piece, because it has very strict rules. And then a machine learning algorithm can learn pretty quickly. So we're talking about the originality in the music.
Yep.
You have automatic music generation for video games, for instance, right?
Yep.
But
video games.
that doesn't sound right because it's repetitive. It's not the spark is missing.
The thing is that I am talking about fully automated music is possible. It's really possible. But the computing power you need for that, it's literally you cannot do it with classical computers. You can, but it's not going to be like a really good composition. Yes?
So you said before you used some generative models.
Yeah.
So what exactly, for example, what I don't understand even with the videos where you're generating input parameters for this OpenCV, what I understand now is OpenCV is some library to do visualization. And you obviously need to feed it something so that it generates something.
No, you can track, you can also with OpenCV do tracking. So the tracking, you can feed it into the machine learning algorithm. For example, track simple stuff, like track a circle, or track the position of a point in the space, the motion tracking. You can also do it with After Effects, and then just use OpenCV to create something. But the thing is that the content creation is built through After Effects.
So are you tracking your in?
Like the legend of the phoenix, I'll end with beginnings. What keeps the planet spinning? The force from the beginning. We've come too far to give up who we are. Break the
We don't want life to the sun. We don't want life to play
that's it. So I'm sorry about the quality of the video. It was literally like one of my server crashed. I have to like render like a 360 again. So.
And the synchronized version is going to be uploaded, right?
Yeah. So what happened is that last time the video got corrupt, so I lost render time. I had to do it again, but I couldn't have like the synchronized version. So if you guys want to see the synchronized version, I invite you to like follow me on my social media, Instagram, for instance. Like I will publish in everything again, and I will put all my social media in the Slack channel that I just created. So now, so any question now? You guys knew what happened here with the style transference of music and photograms and all crazy stuff? Any question?
It basically goes directly back to the question, right? I mean, it wasn't Mozart, obviously, it was a classical music style, but it basically took the style of punk and then the style that you transferred to different music pieces. Right, just to be clear about that, right?
Yep. Yes?
So is it post-processed in any way? Or
No. This is straight from Python. Well, yeah, there is a, okay. There should be a post-processing to synchronize it. But this is straight from Python. That's why it's not synchronized, because I didn't did the MIDI implementation because I didn't have time. But that's a style transfer video. That's what is style transfer. I can show you the original image. I can show you the repo of style transfer, the original one. So I didn't create this, but I just created the music stuff. This is the original TensorFlow CNN convolution neural network. So you have, again, you have a style, you have an image, and you have the final image, which is the style applied for the original image. So it's a painting of everything. So you can even start videos, that's what I did. So as you can see here, this is fast style transfer. So the thing I use this model. Okay, because I didn't train the model because I didn't have time. So this fast style transfer is terrible at quality, but it's fast. So that's why I re-render using fast style transfer instead of the original style transfer. So in a Titan X, the Maxwell Titan X is about 10 milliseconds per frame. But again, it's not like the original style transfer, which is amazing. And that's it for now, for the style transfer. Any questions? No? Yes?
Actually, I tried to implement a style transfer myself, and I have questions about what kind of parameters you use for training.
Music? You're asking for the original, like the image is style transfer or the music one?
The image one.
The image one, you give an image and a deep convolutional network start taking features.
Yeah, but there is a parameter that says how much content you want to take.
Oh yeah, of course. Well, I didn't touch that stuff. You can see it directly from the repo. The repo,
So did you use the model from the repo?
Yeah.
Okay.
Yeah, and I encoded music. So I start transfer to encoded music.
You didn't do the training yourself, right?
Sorry?
You didn't do the training yourself.
No.
Okay.
I did. I applied the model to music.
Yeah, I understand.
I didn't did the training because it was computer expensive.
Yeah.
Okay. So next step is AndtekLIVE applied for DJs. Any DJs over here? Okay, good. So, one of my favorite artists is Michael Jackson. What I did in this example is I gave a table of a bunch of songs of Michael Jackson to an AI. Okay. What the AI do is take that input and do mashup with 3 layers. What's a mashup with 3 layers? It's just putting 3 songs that make sense at the same time. And then you have a timeline with 3 songs of Michael Jackson playing at the same time in a perfect way. So let's see it. So right now I'm not going to use the keyboards. I'm going to use the Karma Lab, which is this device over here. Wait. So this is again, this is MIDI. So this is for like DJs use MIDI too. This is just a console, and the Kronos, which is the drum machine. So that's for the music side. Oh, sorry. So the video was the same procedure I did, but instead of instead of tracks, I used the original video tracks of the song. Okay.
She was more like a beauty queen from a movie scene. She had no mind, but you knew you mean I the one. Why you wanna take on this? That's okay. Hey baby, do what you please. I have the stuff that you want. I am the thing that you need. What is mine? Oh, get right. Just show your face. Roll it right. I'm feeling you. Wanna go out with you. Wanna you be hit by. You been struck by a smooth. Remember, we fell in love. We were young and innocent then. Remember, all again. Just and so I did. Do you remember? What about London? What about Rio? What about all the things that you said we were again? Just another part of me. Things that don't get make you wanna scream. Make you wanna scream. Make you wanna scream. You can't win. You can't break even. Automatic, systematic, full of colors self-contained. Everybody go, do what you like, everybody gotta get innocent on the news. Everybody go, bang, bang, shotgun. Everybody go, all the things that feel me, everybody. Back in your heart. ABC, easy as 1, 2, 3. I'm simple as do, re, mi. ABC, 1, 2, 3, baby, you and me, girl. Oh my gosh, the answer right now, just to tell you once again, who's bad? Eat this.
Okay, so that was the last pre-render demo. Let's render some demos then. So I want you to go to Slack, persons that have a Slack, and go to the actual project index. Okay? I built this up in one day, So please, if I have any mistakes, let me know. So what we have here, let me check if your guys are entering. You have testing up here. I can hear. Nobody's there yet.
Is this the link at the top?
Yeah, it's the one that says, yeah, the one that is pinned. Yeah, I have 2 clients right now.
Yeah.
So what you're seeing right now here is SynapseGL is a SynapseGL control panel. So SynapseGL is okay. I got one more user. SynapseGL is something that I built with a really nice set of person, including Henning. Where is Henning? Okay.
Scott too.
Oh, Scott. Yeah. Where is Scott, by the way?
I don't know.
Okay. So we built on an Ethereum hackathon, a block keys hackathon last year, something to distribute loads using WebGL. We exploit WebGL to be able to run any GPU task on any device, and we're building basically our own CUDA language to run on the distributed network. So okay, I got two more clients. So what we did is we exploit 3JS. 3JS is a 3D graphics library. So this is the phone view. So as you can see, this is a 3D environment. Right now, this is streaming to this control panel. So you're giving me right now computing power without asking. Thank you. But yeah. So I need to render right now sentiment analysis, which is easy, but still, I need computing power. So well, this broke, whatever, but so I need you guys that you have Twitter. Guys that have Twitter, tweet the word AndtekLIVE, followed by a word and a meaning. I will wait like 5 minutes to do this and then take a break while you do this. So tweet AndtekLIVE, hashtag AndtekLIVE, like this, and put a word and the meaning for you. Okay? And I will go to take a rest. I don't know what. Two. No, but the two is 3, 0, 3, 8. 1, 2, 3, 4, 5, 6, 8. So but I did that one.
The next one.
Yeah, the next one, whatever. Pineapples. Okay. So what I'm doing here, okay. So I hit render and it opened me a Jupyter notebook, okay? So this is just HTML script, JavaScript script that loads, like renders run all the algorithm, all the cells at once, but I can use it here. Run all. Let me run all again. Okay. Okay, so we have here pineapple is the name of the piece and the description. Okay?
Sorry.
Okay, so we have this. Beautiful. We have the core base, right? So what's a core base? A core base is basically, okay, so this is E major, sorry. Okay, so we have the base that was AI generated based on the sentiment. And now I'm going to improvise on top of T because I don't want an AI to take my job. Okay, so again, so we have. Okay, let me put the screen. So that's vitamin C actually, like the last progression is C, like C. So that's why I did it. So what I did right now is just I took a base from a machine learning algorithm that was created using sentiment analysis and I improvised on top of that because it's still human. So I don't want to like take humanity from music yet, just yet. So next, I want a guitarist. I want a re-guitarist. Yes, you.
I could have not told him to be but that's what we
I'll give it a shot.
I'm with Nathan.
So okay, so let's do something. Let's get another chord base AI generated from the Python notebook. Thank you for the GPUs, by the way. It was fast. Thank you. So okay.
How are you?
Yeah. So you can come here, and you know how this thing works. Well, you want clean, basically, right? Clean.
No.
So I want you to be.
You want me clean? I'm gonna be clean.
Okay, let's. Okay.
All right, cool.
Okay. So let's choose another randomly one. 9 is the one with 10, whatever.
You have a pick?
Okay, don't. Sorry. Okay,
All right,
so.
I'll just-
Okay, so this is how it's going to work. I'm going to show you the chord.
Sure.
You're going to do the bass. I'm going to improvise on top of that. So let's just see a tweet.
Oh, maybe.
Okay.
See?
No, not yet. So guys, the first one I didn't randomly. So let's choose. I know love. Well, no, let's do cars. Cars.
Oh, so super fast.
Yeah. So it has to be super fast. So I'm going to render now. I'm going to do the same stuff. Room all. Yeah. So it's going to be F sharp major, B, E, G. Okay. So F.
What is that?
That's C. Okay. That's G. Okay. You have G.
This is G.
Yep. Yep. So if you go that's F
sharp?
Yep, F sharp. That's correct. So next one is B.
B.
F sharp, B. Yeah. So E major.
E major.
Yep. Correct. And G major. So, yeah. So. Okay, I'm going to put a drum track.
Was it?
Yeah. So F, B, and then E, and then G. Yeah.
So that worked.
Yeah, that works. Okay, so I'm going to put a fast G because this is B, G. Okay. 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 I'm then going to change the preset of my keyboard and do it with a synthesizer. Okay. Program. Keyboard. Okay. Program. So. Okay, I have it. So it says F, yeah. So okay. Okay, the bass is going to be, yeah. Sorry. Wait a second. Okay, so it's going to be F, yep. So do like a and then B and then E. Correct? And then G and then repeat. And then let's do it with the drums. You ready?
Yeah, give it a shot.
Okay. 1, 2, 3. Well, that car. No, thank you for coming back.
Not
So-
my style, but
Well, I mean, like, it's just AI, right? It's just.
Blame the AI.
So I think that's everything for today, at least because we have. Do you want to play like some improvisation? No. Okay.
not another pick.
Oh right, sorry. You have a pick by any chance? Anyone? No.
No, that's okay.
That's okay.
Maybe I got it. I'm dying. No. No.
You can like let me hear the bass and I can improvise on top of that.
Bass.
Yeah, like the what you got, and then. Yep. You know Starways to Heaven?
No.
No? You don't like it?
No, I do. It's a great song. I just don't know it. I used to. That's great. Thank you very much for the.
Well, I think that's all for today. Next time I will bring more demos. If there is a next time. You want a next time?
Yep.
Okay. Timing, guys. Thank you for
Hey, pleasure. Can we talk later on? Okay?
Yeah, sure.
All right.
So, well, thank you for coming, guys. It was a pleasure to be here with you guys, and thank you for the high-level questions. And hopefully, next time I will explain more. This is my first method, by the way. I'm first concert in Canada, so thank you for making it possible. See you around.